Okay, thank you for this opportunity to do this presentation. This is an ongoing part of my PhD research, and today I'll be talking to you about Fall for Fire, where we are using a product that I've been working on for partitioning modest leaf area index into components of herbaceous cover and woody cover, using modest satellite data, and then apply that to understand fire activities within Africa. My presentation will entail an introduction, get you through the research objectives and hypotheses, the methods where I take you through the partitioning exercise, and then an application of the partitioned product to understand fire activity within Africa, and then finally a summary. I'll not dwell so much time on this because this has already been mentioned in one way or the other in previous presentation, but we see the importance of fires within global ecosystems and how they contribute significant load of aerosols within the atmosphere, so I won't spend so much time with that. When we are trying to understand fires, there has been a lot of research that has been done, and there is a general consensus that fire activity is mainly high within savannas, and most of these are within Africa. And a number of researchers have tried to look into this, and they link fire activities within the globe to the intermediate fire productivity hypothesis, whereby you see there is a hump-shaped relationship where both extremes of the very arid and very low productivity, the fires reduces because there is no biomass to burn. And within the very high productivity, less aridity, we have enough biomass, but we don't have the favorable conditions for it to burn. And this, there's a recent paper that came out just this year attributing fires to intermediate fire productivity. However, this analysis ignore the important role that is played by herbaceous layer to contribute to fire activity, especially within tropical ecosystem, and this is the focus of my talk today. Our research objective is to understand how fire frequency and intensity varies within Africa for both herbaceous and woody, herbaceous and woody leaf area index. And then our research hypothesis, we want to understand, we were saying that burnt areas and fire frequency or intensity in Sub Saharan Africa correlates positively with herbaceous layer, whereas the woody component has a negative correlation with fire activities. And then, therefore, we pose two questions where we want to understand what are the various components of leaf area index within Africa, and then how do these changes affect fire activity within our ecosystems. Our study area, as I mentioned, is Sub Saharan Africa. And we are using MODIS aggregate leaf area index, MODIS leaf area index, and in this case, during my talk, I'll be referring to it as aggregate leaf area index for 2001 to 2013, and a woody cover component, percentage woody canopy cover component that is in prep by Buccini et al. And then we are using mean annual precipitation, and I analyzed data for 1982 to 2012. Our process, the overall processing for the partitioning approach, we are having this MODIS 8-day data, and then we do some, it comes with inherent gaps and noise within it, so we are doing some filling of the gaps and temporal smoothing. Then with the percentage wood cover product and precipitation, we are developing an allometry so that we can come up with a canopy LAI component, which we will use to be able to get the various components of herbaceous and wood cover components for our analysis. And then we come up with the 8-day herbaceous layer component and the 8-day wood cover components. And these two are the ones that I'm using to get the herbaceous annual average maximum leaf area index and wood components, as well as annual average herbaceous leaf area duration, which is basically LAI over time, LAI days over time. And we were doing that using by computing LAI area under the LAI curve. So these are the ones that I will use in my next analysis. And this is just a snapshot of some of the products that we developed. And on your upper panel, we have the annual average maximum leaf area index, and on the lower one, we have the leaf area duration, that is leaf area index in days. Our fire analysis, we want to assess how vegetation and climate influences 3 main fire activities. I'm using 3 different data components: the Global Fire Emissions Database version 4 by Giulio et al. This is the one that we will use to understand changes in burn area fraction within Africa. We also wanted to look at fire frequency, and this we are using MODIS burnt area product. And finally, the MODIS mean annual maximum fire radiative power product. Our approach, we are using regression analysis, where we tried to do multiple linear regression and a spatial autoregressive model. Then we say that fire is our dependent variable, and vegetation and precipitation as our explanatory variables. We therefore use leaf area index and LAD as our vegetation proxies, then precipitation as our climate variable. In the regression analysis, I'm using MLR, as I mentioned earlier, and a spatial lag model. And to test the performance of our models, we were using Bayesian information criteria, for testing our model. Therefore, we applied 2 models, where one, we used fire response to the aggregate leaf area index and leaf area duration and precipitation, whereas in the second, we wanted to explore how fire responds to the various components of vegetation, and these are the herbaceous and woody layer. And we applied these 2 models for both, for the 3 components, as I mentioned, for the burn area, for the mean annual burn frequency, and the FRP. In our model, we found that SLM, or the spatial lag model, performed best for both model 1 and model 2. And this is based on low Bayesian information criterion. We also found that according to the SLM model, there was a positive relationship for total vegetation, leaf area index, and fire activity at statistically significant values. And then leaf area duration was only negative in predicting fire frequency, but we did not see any statistical significance for leaf area duration for percentage burnt area and fire radiative power. And in our multiple linear regression analysis, we found a positive relationships with fires at R squared 0.3. So we can use our model to explain 30% of our fire activities within Africa. For model 2, we have fire activity versus herbaceous leaf area and leaf area duration, and woody cover components for both leaf area index and leaf area duration, and also precipitation. In our model, we found that overall, woody cover component had a negative relationship with fire activities within Africa for all the various, although with fire radiative power, we did not see any statistical significance in our analysis, whereas in our herbaceous LAI component, we see positive relationship with in our analysis. However, we saw positive relationship with precipitation here in this spatial lag model. And for the multiple linear regression, we saw a positive relationship, just as we saw in the herbaceous. We saw a positive relationship for the herbaceous leaf area and mean annual precipitation, while woody cover component had a negative impact on fire activities. And this shows that there was an improved fit for the partition model for percentage burnt area fraction, where our R squared increased from 0.3 to 0.43. That is like 43% can be explained by our analysis, by model 2 in our analysis. Conclusion, I've taken you through our partitioning exercise where we are deriving woody cover components and herbaceous cover components from MODIS data. And we found that woody cover has a negative impact on fire activities in Sub-Saharan Africa, whereas the herbaceous layer has a positive impact on fire activities within Africa, although our models were weak in explaining fire radiative power for the runs that we did. And we also found that burnt area is better explained by partitioned leaf area index model, where the multiple linear regression had a 43% explanation for what is happening with fire activities, compared to the aggregate that can only be explained at approximately 30%. We had expected our leaf area duration to correlate more closely to net primary productivity, but that was not what we found, and these are things that I'm still exploring in my research. And we also expected a negative relationship. However, a test run I did for a number of wet days using a multiple linear regression analysis, I found a negative relationship between mean annual precipitation and fire activities within Africa, and this is something that I want to be looking at in my analysis, in the next phase of my analysis. We find that these findings explain why some areas within Sub-Saharan Africa burn more than others. And as you can see there is a clear pattern where you find high herbaceous layer corresponds closely with the burnt area fraction, as you can see with the GFE burnt area product. And with that, ladies and gentlemen, thank you for your attention. I would like any questions, comments, suggestions. Yes?
Just to combine briefly talk this one, part of the lower leaf area index in herbaceous ecosystems that you saw, for example, Nigeria, has something to do with the more croplands?
Yeah, I did. In our analysis, we are not trying to separate the cropland, the various land cover uses. We're just doing a general analysis for that. But I would really be interested in looking at that, and that is something that I want to see how fire activities behave within different ecosystems.